Okay, so now we move on to descriptive statistics. What I mean by these are the mode, median, and mean of all data sets. So the first one we have is the mode, and this is simply just the most frequent number in a set of data. So using the example here, the mode would be 8, as there are 2 of them, and there are 1 of every other number. Now, a strength of the mode is that it is the only central measure of tendency that can be used for data measurement in a nominal scale. As well as this, it can be easily calculated, which is pretty obvious, seeing that is literally just the most frequent number that appears. However, a disadvantage of them is that there can be sometimes more than one, and this is called bimodal. So, for example, in a data set, there could be 2 or 3 modes in which the researcher wouldn't know which one to go with. Additionally, data such as continuous data is less likely to have a common value or a mode. They will be a lot better for finding the mean of the data. Now we move on to the median. So the median is the middle value of a data set when arranged in numerical order, and it's also known as Q2, which I'll come on to speak about later in the video. The way to calculate it is by seeing how many numbers there are altogether, adding 1, and then dividing by 2. Whatever the answer is, count that many from left to right, and the number you land on will be the median. However, this only works if the data set has an odd number. So, for example, the median in this data set is 10 because there are 11 numbers in the set. That plus 1 is 12. Then divided by 2 is 6. Therefore, I would go 6 along, and the 6th number is in 10. If there were an even set of numbers, you'd have to find the 2 middle numbers. One way to do this would be by halving the amount of numbers there are. For example, if there were 12 numbers, halve it to 6, then go along 6 digits in the set. Once you've found this number, the numbers to the right of it will be the second median. So in this case, it would be the 7th number. That is also the other median. Add these 2 numbers together, halve it, and that will be the actual mean. Now, a strength of the median is that it is less affected by the outliers, as you're only really interested in the middle section of the dataset. Similarly, it best restrains central position and is not strongly distorted by skewed values. Lastly, unlike the mode, the median is good with ordinal, interval, and ratio data. Then some limitations of it is that they are slow to calculate manually with large data sets, and they aren't exactly the best to use when the sample size is too small. Finally, we have the mean. This is also known as the average, and it is the sum of the values added together divided by the amount of values in the dataset. So, for example, in this dataset here, there are 12 numbers, and they add together to make 65. Therefore, we take 65 and divide it by 12, which gives an answer of 5.416 recurring, which to one decimal place is 5.4, which is the mean or average for this set of data. Now, a strength of it is that it includes all the values in the dataset, even if there are outliers. Secondly, it's closely related to standard deviation, which is the most common measure of dispersion. However, a couple of limitations of it is that it can't be used for nominal or ordinal data, unlike the other central tendencies. Also, it doesn't always make sense. For example, it may have a decimal, which it does in the example here. Now we move on to measures of dispersion, which consists of the range, the interquartile range, and standard deviation. So first of all, we have the range. This is the difference between the highest value and the lowest value in a data set. So for example, in this set of data, the range is 25 because the highest value is 35 and the lowest is 10. 35 minus 10 is 25. An advantage of the range is that it's very easy to calculate, no matter how many values there are in a data set, as it only includes the highest and lowest values. Also, it's very good with ordinal data, especially considering it is just so easy to work out. However, a disadvantage of it is that it only uses extreme values, so therefore outliers can really affect the result. The next measure of dispersion is the interquartile range. This describes how much the middle 50% of the data set varies. As mentioned before, the median is also called the Q2, and this is because it's between the lower quartile, which is Q1, and the upper quartile, which is Q3. The lower quartile divides the bottom half of the data, and the upper quartile divides the upper half of the set. Lastly, we have the standard deviation. This is the number that indicates how much the number values in a set of data deviate from the mean or average of the distribution. Some strengths of standard deviation is that it gives an accurate idea of the distribution of data, as you can see the spread across the curve. Also, it isn't affected or as affected by extreme values as range or mean. And the only real disadvantage of this is that it can be very, very hard to calculate manually. In any graph showing a distribution curve, these can vary in appearance due to their different heights and widths. The wider the curve, the more spread out the data is, and therefore the larger the standard deviation will be. Having a set of data closer to the mean suggests there is more precision in the results, and this means the mean is more representative of the data set. However, if many data points are far from the mean, then the standard deviation is far from zero, and if all the data values are equal, then the standard deviation will be 0.